Welcome to EDU World Space.
For this problem, we will choose a planar coordinate system having coordinates x and y with the origin at the launch point of the rocket. And the x-axis is pointing east, the y-axis vertically upward. So we will use subscript e to refer to the point where the explosion occurs, and a and b to refer to the fragments a and b. T is the time that has elapsed after the explosion. So firstly, we'll calculate the motion of the mass center. So the motion of the mass center is independent of the final position of the fragments. So it's as if the rocket has not exploded. So the x component of the mass center, x, is equal to the point at which the explosion happens, xe, plus the velocity of the center, v bar x, times time t. And this is equal to 0 since the rocket is moving vertically upwards. The y coordinate of the mass center is equal to ye plus the initial velocity of the mass center multiplied by t minus a half gt squared, that term that is due to the acceleration due to gravity. And from here, we know that the point at which the explosion happens, ye, is equal to 70 meters above the ground, and the velocity of the rocket at this point is 30 meters per second. So then here we have the motion of the mass center. So at t is equal to 6 seconds, we have that still x bar is equal to 0, and y bar, if we substitute 6 into the equation above, is equal to 70 plus 30 meters per second times a time of 6 seconds minus a half times the acceleration due to gravity, which is 9.81. And we suppress the units here, times 6 squared. And y bar after 6 seconds is 73.42 meters. So after 6 seconds, we have a position vector for the mass center, which is the point as if the rocket had not exploded. Now, let's look at the definition of the mass center. So what does the mass center tell us? Well, the mass tells us that the mass of the rocket, m, times the x component of the mass center should be equal to the mass of A times the position of A, plus the mass of fragment B times the position of fragment B. So we know the mass times the center, the mass center position, the x coordinate of the mass center position 0, should be equal to the mass of fragment A, which is 0.7 kg, multiplied by the position of fragment A minus 80 meters, plus the mass of fragment B, which is 1.3 kgs, multiplied by xb, the x component of fragment B. So we can rearrange this, and we can find the x component of fragment B. And xb turns out to be 43.1 meters. Now we can do the same for the definition of the y component of the mass center. So m, the mass of the rocket, multiplied by the y component of the mass center, is defined as the mass of fragment A times its y component plus the mass of fragment B multiplied by its y position, yb. So again, m y bar is 2 kg into the mass center position is 73.42 meters after a time of 6 seconds, as we calculated above. And this will be equal to the mass of fragment A, 0.7 kgs, times its y position, which is 0, since it's along the x-axis, along the ground, plus 1.3 times the y component of its position, yb, which we wish to solve for. So if we rearrange this equation, we have one equation with one unknown. We can solve for yb, and we get yb is 113 meters. So now we have the x and y components of fragment B. So we can actually confirm that the position of B after 6 seconds has passed is 43.1 meters east along the positive x-axis and 113 meters upwards.